Hi everyone, welcome back to my channel Debug with Purpose. Today I'm going to discuss a very important topic about DSA and one algorithm. But before that, I want to tell you something. So I have a friend who has given interview in the Amazon, but he got rejected. Do you know why? Because he was given a the challenge was like find the maximum sum of k as consecutive element. But what he did, to solve this problem, he used a regular brute force approach. Like it's not his fault. Like we as a developer we do that. That is a very easy task to do it. Like we will add the loops and we'll solve the problem. That's it. But the problem comes why he got rejected because of two lines, two words. That is called time complexity. अगर हम brute force यूज करते हैं तो that takes o(n) square time complexity. But इसका solution क्या है? So we have one algorithm that is called sliding window pattern. I'll explain you the sliding window pattern soon. But before that, I want to show you the code. So see, this is like our for loop. I'm running this loop till array.length and the window sum plus is equals to array ka I minus array I minus k. Okay, so it's like one loop, constant time update. And so the way I said, like brute force takes o(n) square and sliding window take o(n). So what is the reason that why this much difference? Okay, so the difference comes here, like in brute force, for every new position you recalculate the entire window from scratch. Okay, and that is o(n) square. The window size multiplied by the array size every single time. But in sliding window, what happens? It reuses. It reuses the previous calculations. So you just adjust by one element in and one element out. That is on. You touch each element exactly once. So like you can, I showed you in that code, but I'll show you in the live running code also. So the interviewer is not asking for the solution. It just want to know if you know the approach or not to solving the problem. If you know the proper technique or not to solving the problem in very less time complexity. So why time complexity matters? So let's suppose you have 5 lakh of data or n number of data in the production that you need to run. You need to do some activity like saving in the database or doing some anything. Okay, but if you're using brute force, what happen? If you have a less data, then it's fine. But if you have a very large data, sometimes your site will become very slow. Your app will crash. Because of that only we should use some pattern. We should go with the designs. We should go with the data structure kind of things. Okay. So this is the code I have recorded for you. I'll share this slide, not slide exactly. I'll share this running code in my description also. You can find it. See, this is make some array. This is brute force. This is sliding window technique. You can see only two loops we have added. That is different loop, not in one. So I'll run this code. I'll pause for 1 minute, 1 second, sorry. So it's like a speed difference, you can say. Same answer we got, right? But one line difference is this. So see, brute force answer is 13, sliding window answer is 13, same answer, right? But if we are running, if you want to see the time complexity, see, the brute force took 68 millisecond and the sliding window took 8 milliseconds. You can see the difference clearly. It is almost 9x faster. So when to use this pattern? Okay, so we have like one pattern you can use multiple places. Like you have a contiguous subarray window, k elements, whatever. Okay, so applications like whenever you're seeing longest substring, min window substring, max sum, so you can blindly use this pattern. So if you want to know more about the DSA, I'm starting a DSA series. Just stay tuned with the Debug with Purpose. Subscribe my channel, comment, share, and if you have any question, please comment it out. And if you want me to specifically start with the one topic, please comment it so that I can start. Thank you.